Hi guys, and welcome to my YouTube channel again. This is my second video in this YouTube channel where we are solving exercises connected with trigonometry, specifically 11th grade here in Bulgaria. So today we will be doing something that's connected with trigonometry directly, and it's one of the most important things. So the things that we'll be using today and the formulas and the main theorems that we'll be using are the ones that's on your screen now. So we are having the formulas for the sum and difference of trigonometric functions, the first formula, so we're talking about these ones. They can be easily proved by the next formulas for addition of the angles or difference of the angles with trigonometric functions. So we'll be using these two types of formulas. The first are, as I named them, those are the formulas for sum and difference of trigonometric functions, and the ones that's below are the ones that are actually formulas for sum and difference of angles with trigonometric functions. So we're having that sinus alpha plus sinus beta is equal to 2 sine alpha plus beta divided by 2 times cosine alpha minus beta divided by 2. For example, this is the first formula. They can be easily proved, as I said, using these second formulas. There is a proof for them, which maybe in our video we can do, because it will be interesting to see how we can obtain these identities. So now we are starting off, and actually another important thing that you should know here with these exercises is that they are called exercises in triangles. So that means, therefore, we are having angles that add up to 180 degrees. So in this way, we can use different values and they can be helpful through the exercises. You see what I mean throughout the process. So I suggest we start and let's see what's going to happen. So we're starting with the first identity, which is sinus alpha plus sinus beta minus sinus gamma to be equal to 4 sinus alpha divided by 2 times sinus beta divided by 2 times cosine gamma divided by 2. So this is what we should prove. This is our identity. We should prove that the left part is equal to the right part. Yeah. So we are not touching this part. We are working only with this part here. So yeah. So let's start. What we can use here. So from the first thing that we are seeing, we have sinus alpha plus sinus beta, and we have the formula up here. So we can directly substitute the values. So sinus alpha plus sinus beta is equal to 2 sinus alpha plus beta divided by 2 times cosine alpha minus beta divided by 2. So that's what we are using. And now we are having the next part, which is minus sinus gamma. Okay, now it will be easier for us if we name this expression A, and we are only solving A. It will be easier. So we are solving only A. We are not touching B. We'll call this B. And later on, we'll prove that A is equal to B. We should prove that. This is our exercise. So yeah, now we're substituting the values. 2 sine alpha plus beta divided by 2 times cosine alpha minus beta divided by 2 minus sinus alpha. Now what we can use is that we know that alpha plus beta in triangle is equal to 180 degree minus gamma. This is in triangle. Because we are working in triangle, we can use alpha plus gamma is also equal to 180 degree minus beta. We can also use beta plus gamma is equal to 180 degrees minus alpha, and also alpha plus beta plus gamma is equal to 180 degrees, which is always true, and you should know that. So now we can substitute the value for alpha plus beta and using it here. So A is equal to 2 sinus. Here we substitute the value, and instead of alpha plus beta, we write 180 degrees minus gamma divided by 2 times cosine. And here we do not touch them because we can't substitute them. We don't know how much alpha minus beta is equal to. and we are having minus sinus gamma. So now we are having A is equal to 2 sine 100 divided by 2 is equal to 90 degrees, and alpha divided by 2 is equal to alpha minus 2. So we're having 90 degrees minus alpha divided by 2 times cosine alpha minus beta divided by 2 minus sinus gamma. Now A is equal to 2. We know that sinus of 90 degrees minus something is equal to cosine of this thing. So we have the formula sinus 90 degree minus alpha is equal to cosine alpha. We're having this property. And by using it, we substitute 2 cosine gamma divided by 2 times cosine alpha minus beta divided by 2 minus sinus alpha. So now we are thinking of a way to present this sinus alpha. Okay, we can use the formulas for double angle. We know that sinus 2 gamma is equal to we know that sinus 2 gamma is equal to one moment because I forgot the formula, but it's let me check the double angle formula because I forget. Not just, yeah, it's like 2 sinus gamma times cosine gamma. Yeah, this is the formula. So when we have sinus only gamma, we'll be having 2 sinus alpha divided by 2 times cosine alpha divided by 2, and we'll be having this. But because because we are having only sinus gamma, we are substituting only the value for sinus gamma. So we're having A is equal to 2 cosine gamma divided by 2 times cosine alpha minus beta divided by 2 minus sine 2 times sinus gamma divided by 2 times cosine gamma divided by 2. And that's what we are using. Now we can use common multiple, and actually we can actually put something in front of a brackets. For example, if we have a common multiple and the common multiple is 2 cosine gamma divided by 2, here we're having 2 and cosine gamma divided by 2. So what's going in front of the brackets is 2 times cosine gamma divided by 2. From the first bracket we have cosine, from the first part we have cosine alpha minus beta divided by 2 and minus sinus gamma divided by 2. So that's what we are obtaining. And now we are using this just with again the properties. So now we're having A is equal to 2 cosine gamma divided by 2 times cosine alpha minus beta divided by 2, and we can present sinus gamma divided by 2 as gamma to be equal to 180 degree minus alpha plus beta. This is another way to present this because we are working in triangle and we are allowed to do this. So we are having sinus of 180 degree minus alpha plus beta and the whole thing divided by 2. So we're having A is equal to 2 times cosine gamma divided by 2 over cosine alpha minus beta divided by 2 minus sinus of 90 degrees minus alpha plus beta divided by 2. And now, again, 2 cosine gamma divided by 2 times cosine alpha minus beta divided by 2 minus, we are using again the property that sinus of 90 degrees minus alpha is equal to cosine alpha. We are using this and we are applying it here, and we obtain we are obtaining cosine of alpha plus beta divided by 2. Now in the brackets here, we are having the formula. We're having the formula for addition of trigonometric functions. We're having cosine alpha, for example. We're having cosine alpha, or no, we're having the same as cosine x plus, not plus, but minus cosine y, for example. So the formula for that, here we can see it when we subtract, yeah, we have the formula. subtraction of cosines. So we're having 2 times cosine gamma divided by 2. And in the big bracket, we are applying the formula. Minus 2 sinus alpha minus beta, yeah, divided plus alpha plus beta, because we are actually adding the first and the second, divided by 2, and here we are having times sinus alpha minus beta, and here we subtract the second bracket divided by 2. So this is what we have now, for now. And now A is equal to 2 cosine gamma divided by 2 times minus 2 sinus of, here when we release the bracket we have alpha minus beta plus alpha plus beta divided by 2 times sine alpha minus beta minus alpha minus beta divided by 2. That's what we are having. Now 2 times cosine gamma divided by 2 is equal to minus 2 sinus of, here those two betas cancel out, and we have 2 alpha. We have 2 alpha divided by 2. And here we have sinus of, these alphas cancel out, and we're having minus beta minus 2 times beta divided by 2. So that's what we are obtaining now. So we're having A is equal to 2 cosine gamma divided by 2 times minus 2 times sinus only alpha, because we are having 2 alpha divided by 2. Yeah. Oh, no. We have a mistake. Sorry. Very sorry for the mistake. Because here, we are having already 2. Yeah, the number 2. And when we use the formula, we again multiply by another 2. So here it should be multiplied by 2. Sorry for the mistake there. I'm really, really sorry. So we're having 4 here, yeah, in the denominators. So we are having 2 sinus alpha divided by 2. When we subtract, here we obtain 2, and here we obtain minus beta over 2. So times sinus of minus beta over 2. Of course, you know that sine is an odd function. So sinus of minus x is equal to minus sinus x. While if we have cosine minus something, it's always cosine of this thing, without the need to put the minus sign in front. But here it's an important property that you should know. Sinus is an odd function and cosine is an even function. So we are having a is equal to 2 cosine gamma divided by 2 minus 2 sinus alpha divided by 2 times minus sinus of beta divided by 2. So yeah, now we're having 2 cosine gamma divided by 2. These two minuses, the minus here and the minus here, when we multiply minuses, we obtain plus. So we are obtaining only a positive value in the brackets. We're obtaining 2 times sinus alpha divided by 2 times sinus beta divided by 2. And when we release the bracket, we have 2 here and 2 here. 2 times 2 is equal to 4. And when we order first sinus alpha divided by 2. Then we multiply it by sinus beta divided by 2. And then we multiply it by cosine gamma divided by 2. And what we obtain is actually the expression B. So therefore, we proved that A is equal to B.